Okay, so we're going to deal with this today, just the last 10 problems. So after we've kind of finished through today, we're going to have a really good idea what the final looks like. And we'll start reviewing stuff that is the most missed after that. So when I look at this problem right here, it says a certain income of a large population with the normal distribution. As soon as I read the words normal distribution, I know that I'm going to be taking out my calculator, and I'm going to go to my distribution tab, and I'm going to go to normal CDF. And they said with a mean of 60,000 and a standard deviation of 5,000, and they want the salary to exceed 65,000. So I'm going to put 65,000 as the low end. The high end, I'm just going to make a ridiculously big number. You can see that I already did this before on the line above. And then you have your mean, and then you have your standard deviation. And then when you do that, you should get this 15.87 answer right there. Let's try the next one. So on this next problem, what we have is it says the Gallup poll interviews 1,600 people. 18% said they jog regular, and the news ad says the poll had a margin of error of plus 3 percentage points. And we can safely conclude what? And the first one says 95% of the samples are likely to give you an answer within 3% of the true proportion. And that is the correct answer. The 95% of the proportions will do that. The percentage of population of joggers is between 15 and 21. That might be true, but again, it's not always going to be true because our interval doesn't have to include the true proportion every time. It just has to include it 95% of the time. 95% of the population is between 15 and 21. Like, that one's kind of worded weird and it's not right. We can be 3% confident, and that's not true. We can be 95% confident. And then if the Gallup poll took many samples, 95% of them would find that exactly. Well, that's not true. We don't know if exactly 18% is the population. We just know that in this interval, the true population is somewhere in this interval that I've drawn down here, and it's somewhere in between 15 and 21, and we don't know exactly, but 95% of the intervals that we make with this size will include that. So just be very careful on your wording with that. On this, we have to figure out what type of interval this would be. And when you read this, it says the U.S. Department of Agriculture claims a person in the United States is 24.2 gallons per year. A random sample was taken with 120 people in the United States that shows that 23 consume gallons. Well, 120 people is large enough for our z-interval, and since it has a mean and a standard deviation, we know that that's a z-interval. We'll use a t-interval if it's less than 30, and we'll use a 1 proportion interval if we get a proportion. But this one's definitely right because that sample size is large enough for us to use. On this next one, it says a random sample of 55 standard hotel rooms in Philadelphia has a mean nightly cost of $157.70, standard deviation of this, and they want this confidence interval constructed, and they want to know what's the point estimator. Well, if you remember, it's point estimator plus or minus margin of error. So our point estimator for this thing is a mean, and so the mean is that value right there. Let's try the next one. So for this one, we want to determine how to write these hypotheses. Now, normally we do opposites, right? Like equals and not equals. So right off the bat, my brain probably says A. But there is a problem with this. They want the increases. So it's not actually A because they want the one to increase. We know it should be equal to this 5% or whatever. It's actually going to be E. And you might go, well, B and E look exactly the same. Well, we're not actually going to use that p hat or that proportion for this. What we're really trying to find is the true proportion and increase. So it's a little bit tricky. The one on the test will be a little bit nicer than this, but just make sure that when you're reading through this, your normal test is it's the same, and we want to know if the rate's an increase. That's our alternative hypothesis. On this one, it says, in testing a hypothesis, Which of the following would be strong evidence against the null hypothesis using a small significance level? Well, no. Significance is our confidence, so you wouldn't want that to be small. Or our failure rate, so we don't always want our failure rate to be small. Using a large one doesn't make us gain more confidence. Taking a small p-value, yes. So the p-value tells you your percent chance that this kind of thing happens. If that number is really low, we know that that probability is probably nearly impossible. So we don't worry about that one. Let's look at the next one. So it says the Humane Society claims that less than 35% of households own a dog out of the 400 samples, and 150 say they would. Well, if we're looking what kind of interval this is, proportion, because it has a percent. So it makes it really easy to decide. Let's try the next one. We have this, and we have to decide what kind of z-interval or z-test it is. This, again, is going to be, since it's got a random sample of 150, it's going to be a z-interval because they give me a mean and a standard deviation, and it's more than 30. We only use a t if it's less than 30. Try this one. This, they want to test, so we're going to use our calculator, and our tests are under stats. So the biggest thing we need to figure out is what type of test they're running. And it looks like they're running a z-test because we're over 36, so we're going to do our z-test. And that's going to be 750. Our standard deviation is 60. Our sample mean is 745, and we have 36 samples that we're running with. And then we know that this thing should be, they're asking, well, their original assumption is it's at least 750 hours. So when we run this, if it's at least 750 hours, we're thinking it should be more than that. And when we run that, we get our p-value to be 31%. Well, if our p-value is 31%, it has a 31% chance of happening. And they said only fail this thing if it's less than 2. Or only reject this thing if it's less than 2. So we're going to fail to reject this thing because we got a high p-value. Let's try the next one. Same thing here. We got to figure out what test we're going to run. So we're going to go stats. And we're going to go to 1 proportion because it's got a percentage. And it's less than 35% of the time. Whoops. It's got 156 people. Our sample size is 400. And we want this one, they want their claim it says less. So our p-value is less than that. So let's test it. And we get this to happen around 5% of the time. And they said fail this thing if it's under 10%. So we are going to fail this thing, or we're going to reject the null hypothesis because they said if it's under 10%, reject the null hypothesis. So that's what we'll do. Let me know if you need any help. And this is our last review. So once we've got to here, if you can do everything to this point, you're going to do very well in the final.